Welcome to RGES Algebra 2. This is lesson 31A. I'd like to begin with the Psalm 93, and I'm going to read the entire Psalm and then focus on verse 4. The Lord reigns. He is robed in majesty. The Lord is robed. He has put on strength as his belt. Yes, the world is established. It shall never be moved. Your throne is established from of old. You are from everlasting. The floods have lifted up, O Lord. The floods have lifted up their voice. The floods lift up their roaring. Mightier than the thunders of many waters, mightier than the waves of the sea, the Lord on high is mighty. Your decrees are very trustworthy. Holiness befits your house, O Lord, forevermore. And so I've actually written the verse from another version here, but we see here that he's proclaiming that the Lord is great. He is mighty. He is the one who does not shake, though everything else is shaking. And even when the earth shakes, notice how he says in verse 3, the floods have lifted up, O Lord. The floods have lifted up their voice. The floods lifted up their waves. 3 times repetition. And so what we see here is that things around us do shake, whether it be with literal floodwaters, tsunamis, and hurricanes, tornadoes, that kind of thing that can do devastation, or figuratively, in a much broader sense, our world shakes. COVID-19 is shaking the world right now. But this is what I love, is where he plants himself. The Lord is mightier. The Lord on high is mightier. In fact, he is mightier than everything that concerns us. So, my question is, what do you need him to be mightier than today? Fill in the blanks. The Lord on high is mightier than COVID-19. The Lord on high is mightier than this relational difficulty or challenge in my life. The Lord on high is mightier than my sin that keeps feeling like it defeats me. The Lord on high is mightier than my financial burdens or the loss of my job or any circumstance whatsoever that surrounds us. The Lord on high is mightier than my grief and my sorrow and my loss. The Lord on high is mightier than all. So I would encourage you and me to personalize that today, to understand that he is the one unshakable one. And he has us in the palm of his hand when we reach out to him. Now I'd like to go ahead and look on 9.1. This will be our review from the assignment you did last time, and we're going to go over these answers. I'll give them to you orally and then choose several to illustrate the concept one more time. So 9.1, problems 1 through 15, odd. Let me read your answers orally. Now recall what you've been asked to do is graph this. Okay. So if the first one, for instance, we would set this, when it is set to 0 like this, we'll go ahead and set it to y like this. Then we will put together a table of x and y values. We can go ahead and do this one together. I'll show you the whole thing. Let's see, I'll take a 0. Now when I go ahead and plot this, I've got, remember, when I have an x squared term, this is going to plot as a parabola. So we'll come down like that, and we'll come up on this like the other side. Not too good at hitting my dots, but that's all right. And so up, it's going to be coming up like this on this side, and it's going to dip just a little below there. Here. Now the question is then, where does the graph intersect the x-axis, and it intersects there and there. So that would be the same as saying what is the value of x when the y equals 0. And so we read these 2 points off the graph. And so the answer would be x equals -2 and 1, or it crosses the x-axis, okay, at -2 and 1. Or we could say x equals, so when y equals 0, x equals -2 or 1. Several ways I can represent that. So you want to graph it. We will not be showing you any of the other graphs, but you graph it with the table, and then you read out the answers. And I'll just be reading x equals -2. Not sure what I've got going on here, why I've had this extra -2, or a little bit confusing there, or 1. There we go. So that's number 1, and that's what you're expected to do. Now let me go ahead and read off your other answers for you. Number 3, these were the odd problems only. X equals -1 or 4. Number 5, imaginary roots. Number 7, imaginary roots. Number 9, we'll come back and talk about those two. X equals -9 or 3. Number 11, x equals -2 and 1/2 or 3. Number 13, x equals -1.3 or 2.5. And number 15, x equals -3 and 17. Now what we have when we say imaginary roots, visually what you have is you have a parabola, but it doesn't cross the x-axis because it looks like that. Where does that parabola cross the x-axis? Nowhere. Okay, so that's what it looks like visually. This would be number 5 and number 7. And let's look at one of those and tell you why mathematically, or what you're going to see mathematically for that. Okay, so not using graph paper and having my scales a little off left and right but we've turned the corner somewhere after this, okay? And so our parabola, again, it's a little cockeyed because of our graph, but somewhere down here. But the point is I can see I've started going up again, okay? So I can see that, again, I'll apologize for the unevenness of it. If you had graph paper, it would graph out nice and even. But where does it cross the x-axis? Here's my x-axis. Where does it cross the x-axis? Nowhere. And so this is what it looks like visually. Okay. And so that's what we understand when we're looking at 5 and 7. So when it never touches, we say the answer is imaginary roots. So now what I'd like to do is go to the next page and talk about our new concept. Let's first talk about what we mean by an incomplete quadratic equation. Incomplete. Now we remember a quadratic equation has a squared term. So if I have the general form a, some kind of constant, x squared plus bx plus c, this is a equals 0, let's say that. Okay, this is a quadratic equation. My highest exponent is 2. So if I had something like 2x squared minus 3x plus 7 equals 0, that's a complete quadratic equation. But if one of these terms is missing, it is incomplete. So if I had 2x squared, I don't want to, I should not put a line under the first one because I need it to have that x squared term or it would not be quadratic. So let me take that back. If I have 2x squared plus 7x equals 0, and I don't have the third term, then I would solve that, or even if I had it equal a number, I would not want it equal a number. Okay, I would solve that by factoring out my x. So this is one example of an incomplete quadratic equation because it's missing, in this case, the third term, the number. So here I have factored, and I'm going to get two answers. Now, do you remember how to solve this? To solve this is an example of an incomplete quadratic where the third term is missing. To solve it, I'm going to operate under the idea that if I have any two values, a times b, equals 0. Any two values. It doesn't matter what a is and what b is, they're numbers. If the first term is 0, 0 times anything is 0. So my x, if my x is 0, the first term, then the whole thing would be 0. Or if whatever b is equals 0, then the whole thing would be 0. Or if 2x plus 7 altogether equals 0, what would x have to equal? Now you've solved that kind of equation before, you just didn't call it an incomplete quadratic. Okay, so it's an incomplete quadratic because it's missing the last term. And you solve it by setting the equation to 0, okay, and by factoring out the x, or it might be some kind of number before the x that you could factor. Now the second type of incomplete quadratic would be, let's say the second term is missing. So I might have something like this. And here, especially if I write it in this form, I see that the middle term is missing. So it's also an incomplete quadratic. Well, how do I solve this? You probably could think about this very quickly and realize that I would solve this by taking my last term, my negative 21, to the right side as I wrote it here, dividing by 3, and taking the square root. Plus or minus. That's where the two answers come in, the square root of 7. Now I will say that I might have my terms a little confused. Every idea I taught you was correct, but I'm calling this an incomplete quadratic also, but I'm not sure that it is, actually. It is definitely an incomplete quadratic when it only has the x squared term and not the x term. Okay, so the x squared term is present, but not the x term. And I think that that actually is more the proper definition of an incomplete quadratic. All right, so we're looking now, when we're looking at our examples, they all have the x squared term, and none of these seem to have the x term. Let me look at that. I think that's correct. We'll analyze a couple of the later ones together and make sure that's correct. Okay, so we're going to do just this section, this lesson. So I would like to give you 5 examples. These are incomplete quadratics. Number 2 says 3x squared plus 2x squared. Notice all I have here are x squared terms equals 45. Now can you look at this and tell me how you would solve this? It's always good to make a mental plan before you proceed. So my mental plan says I'm going to combine the 2x squared terms, then I'm going to divide, and then I'm going to take the square root. So it ends up being 5x squared equals 45. You see how we do that? Okay, now let's go ahead with number 4. We'll do similar. After I write the problem down, go ahead and put it on pause and do your mental plan and go ahead and work it out if you want to. Or you could wait and watch me work it out. So that's my mental plan. I'll take the 60 to the right side, then I'll divide because I have a 12s squared, and then I'll take the square root. Now let's go ahead and accomplish that. Now when we finish here, we'll take, when we go from s squared equals -5, we'll take s equals plus or minus the square root of -5, and we'll convert that to its imaginary form there. S equals plus or minus I times the square root of 5. Now let's go ahead and give you a couple more examples. My mental plan, I will have to divide and take the square root. So when I do that, I get p squared equals, need to be a little careful here. To divide means to multiply, right, by the reciprocal, and that becomes p squared equals 64. Taking the square root, p equals plus or minus the square root of 64, and the square root of 64 is 8. The problem is getting more complicated, but the plan is not. Very straightforward. Think it through. What would you have to do? What are your steps? Little bit different. I will take the 18 to the right side. Then because this is a fraction, rather than think division, I'll think multiply by the reciprocal, and then I'll take my square root to deal with that. So let's go ahead and execute that. Finally, number 10 will be the last one I demonstrate. There are a couple different approaches that you could have, but I think I will start by foiling this. If we FOIL that, we'll get n squared plus 6n plus 9 equals 6n plus 6. And even though this looked like it had an n term as well as an n squared term, once we have FOILed that out, these will cancel out. And that's why it's also considered an incomplete quadratic. Because we only have at this point, we only have the n squared term. Now, we will take that to the right side, that 9. We'll get n squared equals -3. And we're taking the square root, n equals plus or minus the square root of -3, or I, the square root of 3, making that, of course, an imaginary root. And that's all we have to it. Let me give you your homework. Okay, so do 9.2, 1 through 18 all, 24 and 25, the word problems. And a reminder, you already have taken, supposedly, hopefully, test 7, which covers chapter 8, and I do want it mailed by this Friday. no later than this Friday. So this is a deadline for you, 4/24. And that should not be a problem for you because you've already done that, or should have already done that. That was put out last week. Now, I will give a quiz in addition sent out tomorrow. So if you want to wait an extra day and so that you can mail the quiz back with it, that's fine. If you want to wait on that quiz and just mail the test back, that's also fine. But the test must be postmarked no later than Friday the 24th. Okay, have a wonderful day.